6, 7, 8, 9, 10, and so on. And I have an AN, and this AN is very simple. It's 3 plus 1 over n. Is that simple enough? Right, so what is the first term? 4. What is the second term? 3 1/2. What's the third term? 3 1/3, 3 1/4, and so on. All right, very simple. And isn't it quite clear that limit n goes to infinity of AN is equal to what? 3. Right? This is the example which is simple enough that everybody agrees that this should be true. Right? And then I'm going to take this example of which everybody is convinced of the answer. Then I use this as an example to explain what exactly this is trying to say. Before I do that, I'm gonna draw a picture. Didn't I say that a sequence can be understood as a function from what? N to R? And then n is part of, n can live on the, occupy part of the real axis anyway, right? So I might as well draw a graph of this function. Is that right? So here is 1, 2, 3, 4, 5. So at n equal to 1, what is the value? 4. So it's over here. That's 4. At n equal to 2, that is 3 1/2, and that will be where? Here. At n equal to 3, 3 1/3 is about here. N equal to 4, 3 1/4 is about here. Right? See that? So before long, you can't even, draw the dot that accurately because the next one is very close to this one in height, and both of them will be fairly close to level what? 3, right? And so if I were to draw a line x equal to 3, draw a line x equal to 3, then you see that these get closer, the height get closer and closer to level 3. Is that right? Okay, that's why everybody agreed that the limit should be 3. Right? Okay, now, let's go back to that definition, try to fully understand what's going on here. Somebody give me a challenge. Somebody give me an epsilon. Any number.
1 over a million.
1 over a million? Good. Good try. All right, 1 over a million. So epsilon, let's say, here's a challenge. 1 over a million, 0.000001. Right? 1 over a million. That's my epsilon. Then I have to show to you that I can come up with a capital N. To do what job? Now, if you magnify this, 3, right, plus 1 over a million, and 3 minus 1 over a million, right? They're all very close to 3, all right? So in between, I create a little band, is that right? Very thin, right? So it goes something like this. I magnify that. So here is 3, and here is the epsilon. No? So this is 3 plus epsilon, 3 minus epsilon. Epsilon stands for 1 over a million. And so you have this little band over there. All right? And then I had better come up with a response. And that response, I think, can be met by 1 million. Is that enough? If it is 1 million, if it is greater than 1 million, right? If n is greater than 1 million, what would happen? Not just one n, all the n, all the subsequent n, they have one thing in common. That is that n is big enough, so big that you are sure 1 over n will be less than what? Yeah? Less than 1 over 1 million, which is what? Epsilon. Is that right? So an minus L, that's your limit that you claim is, which is that? 3, right? The difference between an and 3 is equal to what? 3 plus 1 over n minus 3 is equal to what? 1 over n is what?
Less than.
Right? I meant the challenge. Yeah? Okay? Are you with me? I mean, I was given a random challenge, alright? Fairly small. I managed to meet it. However, that doesn't count because it's just one challenge, is that right? So a proper proof will be symbolic in nature, because you cannot say, okay, 1 million is small, granted, right? But it's just, it's just one challenge, right? So there are infinitely many challenges, right? It can be as small as possible, infinitely many of them. And so I really cannot be committed to just one challenge, and therefore I have to commit to all challenges. And therefore I can only symbolically imagine or describing that kind of scenario where a certain challenge such as 1 million is given, right? And I cannot say 1 millions, and therefore I have to say epsilon, symbolically refer to it. And then I did this calculation. That was a calculation done, which is in response to the challenge, specific challenge. And then in general, I cannot do this. I have to polish out this part and do it symbolically. The only thing that I'm allowed to use would be like what? Epsilon. Epsilon everywhere. I cannot write 1 over a million because I don't know what the challenge, how small the challenge. It could be 1 over a billion, who knows, right? So I refer to that as epsilon. I polish out this line of reasoning, presented symbolically, referring not to specific challenge, but to a generic challenge which I can only name by epsilon, in such a way that it makes sense. So that whenever you have a specific challenge, you can go here and then replace everywhere epsilon by 1 million, for example, and then this becomes a valid lines of reasoning, which leads to an minus 3 epsilon value is less than epsilon. So what it's trying to do is that what I have finished proving is that I actually didn't provide a symbolic, honest, rigorous proof, but I'm just demonstrating to you the spirit of it. This is, that's abstract symbolic proof is exactly trying to do something that I have just achieved in response to this single challenge, right? So what happens is that if you give me a challenge such as 1 million, and there is a band, all right, this band, then the response at n millions, what does that mean? That says that, okay, guys, I don't know what happens at the beginning of the sequence, but I can assure you that once you get past a millionth term, all the subsequent terms, its height, its value, that's the height, right, is close enough to the supposed limit, L, in this case 3, close enough to 3, right, within the tolerance, which is this challenge. That challenge is the tolerance. Give me a very small tolerance, I happen to meet it. So long as you wait until 1 million, all the subsequent terms will be within that narrow band in terms of height. Okay, so you wait enough. 1 millionth term is somewhere here. Next term is still somewhere here, and next term is still somewhere here in terms of height. Okay, so the value is very close to what? 3. Within plus or minus epsilon. That's the tolerance. Give me a challenge, which means give me a tolerance. Then I can meet that tolerance. I can stay within that tolerance, once I get past a certain term. But your challenge could be arbitrarily stringent. And therefore, I have to be prepared to symbolically reason that no matter how stringent it is, I will be able to meet it. Right? And that certainly shouldn't be like this. It should be, more polished, symbolic form. But it should be very similar to this. All right? So that's limit. Got it? Okay. Now, just like in last semester, if you were going to do every single problem, every limit problem this way, it's excruciating. All right? You'll see that you're reinventing the wheel.